Amaikis. It's been a while since I last made a video. Life has been busy and I didn't have much time for shop stuff. Also, we moved the machine shop to a different room in our space, and most of my free time I spent moving stuff, renovating the new room, and renovating some other places in our space, so not much to show there. But right now things are finally calming down, so after missing last year, I can enter the toolmaking competition this year again. Taking inspiration from Quake's workshop, I'm going to make some hold-down clamps for the grinding vise on my milling machine. I bought the mill early last year, used it a bit then to make fixture parts for the experiment of my bachelor's thesis, but since then it mostly sat and still waits for the renovation to progress to the point where it can be moved from its temporary table to the new mill stand I already built. Still some work to do before that, but getting there sometime soon. The mill is a BF2 size or G0704 in the US. This variant takes SK30 tooling in the spindle. I run it with that 100mm grinding vise. Still set up with some clamping set hardware. Worked for what I needed it to do last year, but now it's time to make some proper hold-down clamps. Inspired by Robin Renzetti and Stefan Gotteswinter talk about the benefits of leaving the vise on the table all the time and having proper chip guarding all around the machine. I had some ideas for additional features that I wanted to incorporate into these hold-down clamps. Let's have a look at the drawing and I'll show you what these features do. This is the general arrangement. The mill table down here, vise body here, and this is the clamp. The clamp has a small lip down here that sits on the table, a relief, and then over here this ridge engages the clamping slot of the vise, and it's bolted down to a T-nut with an M10 bolt. The first feature I want to add relates to the T-slot cover I like to have on my mill. It's just so convenient not having to clean out the T-slots every time you're finished with a job. But one thing that bugs me with the cardboard version I have on there right now is there's this gap between the cover and the vise, and chips fall down there, and I don't like that. So what I want is a small piece that covers up that gap, provides a lip here so chips just fall down onto the cover. For this piece I'm adding 2 M4 holes in the side of the clamp so I can screw this on. The second thing is inspired by the Garadi vises like Stefan Gotteswinter uses. They have some tapped holes in the top of the vise jaws, and that is super convenient for holding parts on top of the vise so you don't have to pull the vise off the table when you're doing work that does not fit into the vise. Since the grinding vise is hardened and I can't really tap into that, I'm going to drill and tap some holes into the clamps that I can mount clamping hardware to. The last thing, with that additional holes and the socket head cap screws that bolted down to the table, I don't want chips to accumulate in there, so the last thing I want to add is a top piece like this that just drops on and is held in place with a pin that goes into a 3mm hole here. That covers all that up nicely. Chips just fall over and onto the cover, and if I need the holes I can just pull it off and put it back on after I'm done. This is the dimension drawing. It's a bit convoluted since I already added all the coordinates I need to move the mill table to later for drilling, but as you can see down here, this is how the clamps will look like. 3 10mm holes to bolt it down to the table, 2 M4 holes to accept the side piece, 6 M6 holes for clamping hardware, and 2 M3 holes for putting down the top piece. I have prepared 2 blanks of 30x30 C45 steel, 150mm plus some allowance long, and the first step is to square up the ends. Running at 150 RPM, 0.1mm depth of cut. and a 50 micron clamp cut finish pass back. Dropping down for the second pass. And that leaves a nice finish. Drilling and tapping the M4 holes for the side attachment. Next up, I laid out all the vertical holes on the top side. The 3 10mm holes for the clamping bolts, 6 M6 holes for clamping struts, and the 2 3mm holes for putting down a top piece. Also, in this back corner, there needs to be a piece removed to clear this lead out of the clamping slot in the vise, and I'm going to pre-drill this corner so the milling goes easier. I'll do this off camera, it's just more of the same, drilling and tapping. I'll see you when it's done. Okay, I drilled all the holes, tapped the M6 holes, I left the 10mm holes without the countersink. I don't have the right size countersink here, so that will have to wait. And the next thing is milling away this back corner here using a 6mm carbide end mill, taking the full 10mm in one depth, nibbling away from the back to the front. Both pieces are drilled now and have these corners milled out. The next step is to flip them around and mill off 2mm to get them to the final height of 28mm. Using the shell mill again, running at 150 RPM, full width 0.2mm step downs. I'm not using the shell mill. The mounting screw that mounts the shell mill to the arbor sticks out below its cutting edges, so yeah. New plan: 12mm high-speed steel roughing end mill. I laid out all the lines for milling the steps next. First we will mill out this big chunk here, and with that we will form really the only semi-critical dimension of this part. That is the height difference between this lip back here that will sit down on the table and this ridge here that will engage the clamping slot of the vise. I will mill out this section down to the ridge first, leaving the relief intact. That just makes measuring from this height down to the ridge easier. After that, I will mill out the 0.5mm depth for the center relief section. I measured the necessary height from the table to the clamping slot with gauge blocks. The sides are a little bit different. The left one is 15.5, The right one is 15.6 millimeters. Using the 12 millimeter high-speed steel roughing end mill again, I'm going down 14.5 millimeters, leaving 1 millimeter for later finishing, 0.2 width of cut. I increased the width of cut to 0.4 millimeters, and I'm also doing a 0.1 millimeter clamp cut pass on the backstroke. I roughed out the step. I left 0.5 millimeter on the wall and also 0.5 millimeter on the floor. Next, I'm going to switch to a different end mill to finish it. I finished up the width of 10 millimeters, and next I'm going to finish the floor. First, that surface finish is terrible. The 10mm end mill didn't clean up the whole 10mm width, so clearly the corners are chipped, but we should at least be to final depth. And we are. Here are both parts after milling. And here they are after some quality time with files and sanding sponges, rounding over all the edges and corners and brightening up the surfaces. I pulled the vise off the table, cleaned the vise, and then put it back on with the new hold-down clamps, temporarily with the old bolts. Yeah, I'm really happy. This turned out great. The next step is to fabricate new T-slot covers and then design side pieces to cover up the T-slot cover and a top piece that covers up all these holes now so they don't catch all the chips. And here's an example how the holes for 6mm clamping hardware can be used to fixture irregular sized parts on top of the vice jaws. This was a lot of fun. Thanks to Emma for hosting the toolmaking competition again. Thanks to R. Stephen Lang for co-judging. Thanks to ShadowDuck500, Tommy Gun Machining, and Stefan Gotteswinter for donating prizes. And thank you all for watching.